Hello. I'm going to talk about CS343, which is Concurrent and Parallel Programming. And the course has two major components to it. The first is you get to practice some more C++. The course is taught in C++, and all the assignments will be in C++. And I like to try and add all sorts of extra language features in the course so that you get to learn more about the language. That's fun, but more interesting, the course is all about a control flow. So how do you move around in a program? And in a data structures course, you learn about how to select a proper data structure. And in this course, we're going to go over all sorts of different control flow. And then you'll be able to look at a problem and select the best control flow, select the best data structure, put the two together, and you'll be able to have an excellent program. All right, so the requirements are CS350 and the E and CE 354. Computer science students only. Fall and winter. Normally the fall has two sections and the winter has one, so take that into account. And so what I'm going to do now is in the next 45 seconds I'm going to do the course, the whole course. All right, so let's see if I can go through it all. So let's start in 246. In 246 you learn that a routine can call each other, and so A can call B, and B can call C, and then C goes back to B, and B goes back to A. All right? So that's easy. So then what we're going to do is we're going to talk more about advanced kinds of control flow. So let's start with something called exceptions. In that scenario you have A calls B, B calls C, and C jumps all the way back to A, terminating B in the process. All right? And so there's many, many interesting things that you can do with this kind of advanced control flow. All right, let's go up a little more complexity. We'll have A call B, B calls C, and then C does not terminate. It goes back to B, and it stays active. And then B can actually go back to C multiple times, and in fact, even A can go back to C. And that gives us a new kind of control flow that's extremely interesting, and in fact, Python has it now with the yield statement. And finally, the most interesting part of the course is the concurrency part. And that's where we have A and B and C. They all start executing simultaneously, and they can all terminate at any time. All right? And so that's the fun part, and we get to do some really interesting things there. So we're basically going to extend the material that you will take in CS350. We're going to be working inside of the programming language versus inside of the operating system. So in the operating system, a lot of the concurrency is hidden. In the language, we're going to try and expose it as much as possible and play around with it. The kind of environment that's being focused on is shared memory, multi-core systems. So on your laptop, you have 2 to 4 cores. On servers, we have 6 to 32, and then on larger machines, you have 48 and more. The undergraduate environment right now has 3 machines with 48 cores, and then we're using that to do some interesting assignments in the course. So basically, we're focusing on structuring, implementing, and debugging complex control flow, and in particular, concurrency, which is the most advanced form of control flow. Workload is moderate plus. Everybody just, the students always grade the courses just a little bit above normal. Mark breakdown, 40% assignments, 20% midterm, and 40 final. There's 5 to 6 assignments depending on the instructor, and normally the final assignment is done in pairs. And this course is useful for, but not required for, some of the other courses. So if you take concurrency and you add information management, you get some of the database courses. If you take concurrency, non-shared memory, you get the distributed systems and the computer's network. And finally, if you take concurrency and time, you can get the real-time course, which is going to be discussed shortly.